All right, this video is going to go along with the notes. There are notes under your topics page that you can download. Also, if it's a little bit easier for you to do notes on paper while watching the video, I suggest that. There are paper copies as well. Just ask for one. There's also a worksheet that is going to be turned in. So the notes that go along with this video are not turned in. The worksheet that's in the assignment center will be turned in. So make sure you download that worksheet because I'm going to have you pause the video and do a problem for the worksheet after every problem, okay? So download that from the assignment center, and you also have a notes page. So you're going to have 2 pages. Only turn in the assignment center one. Turn that into the assignment center by the end of class. Problem 1 says to graph this line, f of x equals 2x minus 4. Well, remember, this, anytime we have f of x, that's like saying y, right? So it's like saying a fancy way of y equals 2x minus 4. And we know how to graph that. That's a linear equation with a y-intercept of -4 and a slope of 2. So I'm going to graph that in blue. Okay, I have my function graphed there. Then it says find and graph the inverse, f inverse of x. Well, remember, we talked about yesterday, the inverse is when we switch the x and y's, right? So in green, I'm going to do this. We're going to switch x and y. So we're going to rewrite the function switching x and y. You're going to solve for y. So we're going to add 4 to each side. We're going to divide by 2 on each side. So we get 1/2 x plus 2 equals y. So the inverse function is actually 1/2 x plus 2. And we know how to graph that as well. So go ahead, and that's a linear equation. Y-intercept on 2, slope of 1/2. All right, I've drawn my function in, my inverse function in. And it's also asking now for the domain and ranges of each. So the domain of and range of both of these is actually from infinity, or negative infinity to positive infinity. So of my actual function, my domain is going to be from negative infinity to positive infinity. My range is also from infinity to infinity, negative infinity to positive infinity. Domain for Sorry about that. My domain for my inverse is negative infinity to infinity, and my domain for my range is also negative infinity to infinity. Just because they both go, both directions forever and ever, there's an arrow there. One thing we did talk about yesterday as well is that the function and its inverse are always reflections over the line y equals x. So excuse my squiggly line here, but this red line that I just drew in is y equals x. So remember, keep this in mind. Any graph and its inverse are reflections over the line y equals x. So go ahead and pause and do number 1 on your worksheet if you haven't done it already, and come back to the video. All right, the second problem is asking us to do the same thing. Graph f of x equals x plus 5 cubed minus 3. That is a cubic function with the origin at -5, -3, right? So let's go ahead and draw that in. I'm going to do it in blue. All right, I have my cubic function drawn, and just really quick, the domain, so it goes left and right forever and ever. My domain is negative infinity to infinity. My range is also negative infinity, goes up and down forever and ever, negative infinity to infinity. So that's just something to keep in mind. Okay, finding the inverse function. We are again, so if this is y equals, we're going to switch x and y. So I'm going to write x equals and y plus 5 cubed minus 3. So I'm going to start solving for y. So I'm going to add 3 to both sides. I'm going to take the cube root of each side. So when I take the cube root of the left, it looks like that. When I take the cube root of the right, I'm left with y plus 5. Then I'm going to subtract 5 from each side. Cube root of x plus 3 minus 5 equals y. And we can write that as f inverse of x equals cube root of x plus 3 minus 5. All right. So I'm going to draw that in. That is the cube root function with an origin at -3, -5. I'm going to draw that in green here.
All right, so my domain is going to be negative infinity to infinity, and my range is, again, negative infinity to infinity. If I draw in that y equals x line, something to keep in mind is that when I draw in that line y equals x, that red line, that is the mirror for these two graphs. They are reflections over the line y equals x. Go ahead and pause, and I want you working on number 2 on your worksheet, then come back to the video.
All right, number 3 is asking us to graph this square root function. So this is a square root parent function, and its origin is going to be at 2, 4. So I'm going to go ahead and just graph that in blue. Okay, I have my square root function drawn in, and my domain. Now my domain, take a look. This does not actually start, my x values don't actually start until about right here, right? And that is at 2. So my domain starts at 2 and then goes on forever. So I'm actually going to write that in. My domain starts at 2 and goes to infinity. My range, same thing. It doesn't go on, it doesn't start from a negative infinity. My range starts here at 4 and then it goes on up forever, right? So my range goes from 4 to infinity. Okay, now it says find the inverse. Same kind of deal. We're going to switch x and y. So this is going to be x equals, oops, I'll use the marker. All right, it's going to be x equals square root of y minus 2 plus 4. Subtract 4.
Equals y minus 2 square root of y minus 2. To get rid of that square root, that radical, you have to square both sides. So when I do that, on the left, I'm going to get x minus 4 squared, and on the right, I'm going to get just y minus 2. Then I'm going to add 2 over, so x minus 4 squared plus 2 equals y. And so my inverse function is f inverse of x equals x minus 4 squared plus 2.
All right, now here's the thing. That is a quadratic. So when I go ahead and graph that entire quadratic, this is what I'm going to get. I'll do that in green right here. All right, so does that look like the reflection of that blue? No, not really, right? So if I was to draw that y equals x line, there's not a reflection of it. All right, so I drew that in just so you could see that is definitely not a reflection. Why is that? That's because the square root function is kind of just like half a parabola. So when I try to take the inverse and I draw the inverse, that should also be just half of a parabola. So I'm going to have to restrict the domain. I want to restrict the domain so that we only use half the parabola. If I could restrict it so that just this part right here is used, that's the best way to do it. So I'm going to restrict it so that x is only greater than 4, greater than or equal to 4. All right, so I went ahead and I cut off that parabola halfway. Now, does this look like a reflection? Yes, it does, right? So I cut it off so that my function only happens, my quadratic is cut off so that only when x is greater than or equal to 4 are we going to draw in. All right, and we're going to know this. Also, I want to show you a trick. What is the range? What is the domain for this? The domain for this function is, like I said, when x is greater than 4. So my domain is 4 to infinity. Actually, I should put brackets, right, on all of these things because it's or equal to. My range starts at 2 and goes up. So my range is from 2 to infinity. Do you notice something? My x's and y's get switched. That means my domain and ranges get switched. So there is your hint there. Okay, you're going to cut off. If your range in your original function is 4 to infinity, that's going to be your domain restriction in your inverse. So I would like you to, this is your final answer for this. You have to put in that domain restriction. Without it, you're going to have a whole parabola. It is not going to look like a reflection. So I'd like you to pause this video, go ahead and do number 3 on your worksheet, and then come back. All right, last one. Number 4 is asking us to graph x squared minus 2 if x is greater than or equal to 0. All right, well, first of all, let's just graph x squared minus 2. So x squared minus 2, I'll do it in blue. Looks like this. It's a quadratic that is moved down 2 spots. All right, there's my quadratic. Now, there is a restriction on it, right? If x is equal to greater than or equal to 0, excuse me. So I'm going to have to erase that. Now, the question is, why is there a restriction there? Well, first, is a parabola a one-to-one function? Well, the answer is no, and you guys know that. But why does it matter? Okay, why does it have to be one-to-one? Now, if I was to reflect this, go ahead and try to reflect this parabola. I'll give you a hint. It's going to look something like that. Okay, what's the problem with that green? That green parabola, sideways parabola, is not a function, right? It doesn't pass the vertical line test. So in order to, that's why all of our original functions need to be one-to-one. Because then if it's one-to-one, our inverse is going to end up being a function. If it's not one-to-one like this parabola, our inverse is not going to end up being a function. That's why we're going to have to restrict the domain. That's why anytime you're given a quadratic and you want to find the inverse, the domain is going to be restricted because it needs to be one-to-one. All right, so let's actually go ahead and find the equation of the inverse. So if this is, again, y equals, so we're going to switch x and y. We are going to put x equals y squared minus 2. We're going to add 2 to both sides. So we're going to get x plus 2 equals y squared. How do we get rid of y squared? You take the square root of both sides. Remember, when you take the square root of something, you have to include plus or minus x plus 2 equals y. Here's the thing. When we write our inverse function, we are not going to include the plus or minus. We have to choose if we're going to include plus or if we're going to include minus. If we included both, we would get, I'm just going to sketch this for you really quick. A positive square root function looks like this. A negative square root function looks like that. That's your whole parabola. That's the positive square root function and the negative square root function. We do not want both of those. We only want one. Here's what you're going to do. You're going to look. When I created my, I never actually cut this off. When I created my parabola, restricted at x is greater than or equal to 0. So when we created our parabola, we erased the negative side, right? We only kept the positive side. So when we write our square root function, we're only going to keep the plus of the plus minus, because when we had originally drawn in our quadratic, we only kept the positive side of the quadratic. So we're, again, going to just keep the plus of the plus minus of the square root function. Let's say, just for a hypothetical situation, let's say that my original parabola was just restricted on the negative side. Okay, so if it said only when the domain, when x is less than or equal to 0, when I do my inverse, I would then keep the negative of the plus minus. Okay, I would keep the negative. But again, because we restricted the positive in this case, so we only had positive, we're going to keep the plus of the plus minus of the square root function. Now, before we draw this in, I just want to make a little kind of prediction. So the domain of our original function in blue, our domain starts at, let's see, it starts at 0 and it goes on forever. So it starts at 0, goes on forever. Our range starts at -2 and it also goes on up forever. So let's make a prediction. What's our domain of our inverse function supposed to be? It should be -2 to infinity, right? Because we're going to switch domain and range. We're switching x's and y's. What's our range going to be? Our range is hopefully going to be from 0 to infinity. Now let's double check. We know how to graph a square root function, right? So let's graph that. It is going to be a square root, and it's going to be shifted. Does that match our domain and range predictions? Yes, it does. Our domain goes from -2 to infinity. Our range goes from 0 to infinity. We don't have to put any domain restrictions in this function right here because the square root function is in itself restricted. Okay, we kind of already dealt with that also with that whole plus minus discussion. So go ahead and pause the video, and you are working on number 4 in your worksheet, and you are going to turn that into your assignment center, and then you are working on your homework, and you hopefully have a great weekend. All right, I will see you on, not Monday, Tuesday.